This third video on chi-square, we're looking at chi-square as a test for independence. And so for this, we have a column and a row. We will look through things. And basically we have two versions of the null hypothesis. Remember, H sub O is sub 0 is a null hypothesis. Either that there's just no relationship between the two variables, or that the distributions have the same shape for all categories. Basically, we're kind of saying the same thing with each one of those. For one of the things that change here is how we figure out the expected frequency. We're going to take the column total for a particular cell times the row total for that cell, multiply those two, and then divide that by the total sample size. And when I show you the example, I think that should be clear to you. And then our differences as well in figuring out the degrees of freedom. We have the number of rows we have minus 1, the number of columns we have minus 1, we multiply those two together. So if we have this example here, we're looking at gender differences in body shape preferences. So if we're looking, so men and women are given pictures of women, if you will, silhouettes though of women, for that they're able to tell kind of the body shape of the woman. And so which categories do they seem to prefer? They prefer the somewhat thin, the slightly heavy, or the somewhat heavy categories. See, we've got our total for for women and men. So just the number of women who participate in the study, and the number of men. So we have differences there, which is typical, by the way, in research today. There's many more women usually who participate in studies than men. And then we've got our totals here for each of the categories of preferences here. And then we want to see are there differences here between men and women for this. So total-wise, it seems to be very similar here and less of a preference for the somewhat heavy. And then we've got our total sample size right here. What we need, so we've got our observed frequencies. What we need to figure out for each, excuse me, for each cell is we need to figure out the expected frequency. How is it that I was saying to do that? We take the row total that corresponds with this cell times the column total for that cell. And then, so that's 80 times 40. And then we divide that by our total sample size of 140. 22.86. Okay, very similar to what the observed frequency was. And so here it's for this cell 40 times 60 divided by 140. 17.14. Again, this one will be exactly the same. 22.86, right? So we're just taking 40 times 80 divided by 120, and same thing for here. It's the same. By the way, in your homework problem, you could have different numbers here, so note that you're going to have to calculate it differently based on what the totals are for each of these. Same thing here, 22.86, and here, so it should be 17.14, and then here this one's different. So 80 times 20 divided by 140. The expected there is 11.43. And for men, 20 times 60 divided by 140, 8.57. Okay, we've got our observed and our expected frequencies. Now we're just going to have more cells here that we're going to add up the numbers for. So for our chi-square, this part's the same as what we've always done. Observed minus expected, square that, divided by the expected frequency. Plus, now we move on to this cell. 25 minus 22.86, square that, divided by 22.86. 18 minus 22.86 squared divided by 22.86 plus 8 minus 11.43 squared divided by 11.43 plus, we'll move down here to give us a little more room, 11 minus 17.14 squared divided by 17.14 plus 15. You'll notice it's not difficult, it's just kind of labor intensive. I'll get that later. 17.14, 22 minus 17.14, we'll square that, divide by 17.14, and then our last one, 12 minus 8.57, we'll square that difference, divide by the observed frequency, or expected frequency, excuse me, at 8.57. Let's go through each one of them quickly then. We've got 29 minus 22.86 squared times, sorry, I got a bad calculator here, divided by 22.86, 1.65 plus 25 minus 22.86 squared divided by 22.86. You notice that didn't contribute much. The observed and the expected were very similar to one another. Oops. 18 minus 22.86 negative 4.86, 23 0.03, 8 minus 11.43, I'm assuming you'll have a more advanced calculator than I'm using here for this example. But to demonstrate to you that you can use any calculators for this class, as long as you have the square root button, whoops, 17.14 squared divided by 17.14, 2.20, 15, whoops, had the correct answer. .27 plus, we're on to this one here, 22 minus 17.14 squared divided by 17.14, 1.38, and then finally our last cell, 12 minus 8.57 divided by 8.57, 1.37. We add all of these up. .13 is our chi-square. As we work through, we're trying to get we need to get our degrees of freedom now for this. Degrees of freedom equals number of rows that we have minus 1 times the number of columns that we have, minus 1 times 3 equals 3, our degrees of freedom. We look this up into the book to find our cutoff for the chi-square. Page 595. We have alpha of 0.05, degrees of freedom are 3, 7.81 would be our cutoff for this. 7.81, 9.13, reject the null hypothesis. And then as we look through this to interpret the data, we look back at your observed and your expected frequencies, and where do you see the big differences? We see it here, that men were more likely to like somewhat heavy body shapes as compared to women. We see this for the slightly heavy as well, the differences between men and women, and then we see these differences on the other side as well. For the somewhat thin, that the men were less likely to prefer that as compared to the women. Women were much more likely to prefer that category. So we see these gender differences between women and men in the preferred body shape, their body shape preferences.